Bismillahirrahmanirrahim. Rabbi shrah li sadri wassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shairoz Abdullah, and now today we are going to discuss what is refractive index, what is Snell's law, and what is total internal reflection, right? If you remember, in the previous lecture we have done with different things like what was refraction of light and what was the cases over there we have discussed in the previous lecture. Okay, and this was all about yesterday's work. Now today we are going to discuss lecture number 6. Right, this is lecture number 6, class 10th, physics, chapter number 12, geometrical optics, right? Okay, now we are going to start with refractive index. Look, refractive index is a kind of a ratio between sine of angle of incidence to sine of angle of refraction. Refractive index is basically represented by a small n. We can write that the ratio of sine of angle of incidence to sine of angle of refraction is known as refractive index. Okay, it is represented by n, and we can write that n is equal to sine of angle of incidence divided by sine of angle of refraction. We can define it by another way as well. Look, the speed of light in air or vacuum, the speed of light in air or vacuum, we can write that the ratio of speed of light in air or vacuum divided by speed of light in any medium. The ratio of two things. What? The speed of light in air or vacuum divided by speed of light in any given media. Okay, we know that refractive index is represented by n, and speed of light in vacuum or air is represented by c, and speed of light in any given medium can be represented by v. So we can say that n is equal to c by v. Okay, this was the second definition of refractive index. Now look, on which of the thing refractive index depends. Do remember one thing, refractive index depends upon nature of the material, medium. Like different material has its own refractive index value, because refractive index is a characteristic property of a certain material or media. Okay, so do remember one thing, refractive index is the what? Refractive index is characteristic property of a substance, right? Refractive index value will be always greater or equal to 1. Okay, refractive index value will be always greater or equal to 1. There are different examples of refractive index values, like for air it is 1.000271, for water it is 1.3, for water refractive index is 1.33, for benzene it is 1.501, for diamond it is 2.417. Now this was refractive index. What is refractive index? Refractive index is the ratio of sine of angle of incidence to sine of angle of refraction, known as refractive index. Another definition of refractive index was the ratio of speed of light in air or vacuum divided by speed of light in any medium, n is equal to c by v. This was also about the two definitions, right? So this was all about refractive index. Now we are going to discuss what is Snell's law. You know, Snell's law was represented by Snell in 1621. And what is actually Snell's law? You know, Snell's law is actually a relation which says the product of refractive index of first medium with sine of angle of incidence is equal to the product of refractive index of second medium with sine of angle of refraction. This is known as what? Snell's law. Snell's law is quite simple. It is equal to, like its mathematical expression is equal to n1 sine theta I is equal to n2 sine theta r. Okay, how we state Snell's law? Snell's law can be stated as the product of refractive index of the first medium with the sine of angle of incidence is equal to refractive index of second medium with sine of angle of refraction. This is known as what? Snell's law. Now this was all about Snell's law. Let me discuss the new topic, that is total internal reflection. You know, total internal reflection of light. You know what is total internal reflection of light? As we know that in the previous lecture we have discussed, when ray of light enter from a denser medium to rare medium, it do what? It bends away from the normal. Total internal reflection is dependent upon that rule. When ray of light enter from a denser medium to rare medium, it bends away from the normal. Now look, before going further with refractive index, we need to understand what is critical angle. You know, critical angle is that incident angle for which angle of refraction is 90. First of all, we understand critical angle, then we understand okay, then we will proceed it further. Okay, what is critical angle? So we say that that incident angle in rare medium for which angle of refraction in the denser medium is 90 degrees, that incident angle is known as critical angle. Okay, what is critical angle? That incident angle in rare medium for which angle of refraction is 90 degree, so that incident angle is known as what? Critical angle. Okay, acha. So that incident angle is known as critical angle for which angle of refraction is 90. Okay, critical angle value for diamond is 24.4, for glass it is 42, for water it is 48. Now let me discuss the detail of it by using this diagram. You know what is happening in this diagram? Look, this is boundary between two mediums. This red line is what? Boundary between two mediums. Okay, now this is, we are having a light source. Okay, now what is happening? Over here we are having air, and over here we are having glass. So air is rare medium and glass is denser medium. We are explaining this diagram right now. Okay, look, ray of light comes from denser medium to rare medium, strikes the boundary, and according to the rule it should follow this black dotted line, but it does not follow that dotted line. It bends away from the normal as shown by this dark black line. Okay, this is first case. Now what is happening again? The second ray is coming and striking the same boundary. According to the rules it should follow this dotted line, but it does not follow. It bends away from the normal like this. Okay, now third case, the same ray of light is coming and it is, according to the rules it should follow this dotted line, but it does not follow that dotted line. Okay, it become very parallel to the boundary of the medium. Now look, over here if I see, the angle of refraction is what? Angle of refraction is 90. So from there we can define the critical angle. Now what is critical angle? That incident angle for which angle of refraction is 90 degrees, that incident angle is known as critical angle. I is equal to C if R is equal to 90 degrees. Okay, now this is very tricky. Now if further rays will come and will strike the boundary, they will be not refracted in the rare medium, but they will be all reflected in the same medium from where they went. That is why this is called total internal reflection. Total means all the light will reflect back in the same medium from where they are coming. Do remember, if angle of incidence is greater or equal to critical angle, there will be no transmission of there will be no transmitted ray for it. Okay, now there are two basic necessary conditions for total internal reflection. The first is the ray of light must enter from a denser medium to a rare medium. Number two, the angle of incidence must exceed the critical angle theta c associated with a material. So these two conditions must be fulfilled for the phenomena of total internal reflection. Now we have to derive a value for critical angle. Okay, now how we will do? we will utilize Snell's law. If you remember, we have done with Snell's law over here. Now we will utilize the same expression to derive a result for what? Critical angle. We know that from let's discuss mathematical expression from Snell's law. We know that n1 sine theta I is equal to n2 sine theta r. Okay, now n1 will be as it is, sine will be as it is, incident angle will be replaced by critical angle. Let me represent it by c or theta c. Some people represent it c by theta c. It's okay, both you can utilize. Okay, now n2 will be as it is, sine will be as it is, theta r instead of theta r we will write 90 over here. Now n1 sine theta c will be as it is equal, and n2 will be as it is. Sine 90 will give you 1. Okay, this 1 will be multiplied with n2. We are going to get a result n1 sine theta c is equal to n2. Now what we do, dividing n1 on both hand sides, we get sine theta c is equal to n2 by n1. This is the basic expression for critical angle, which will be utilized in finding the numerical problems. Like if we have the refractive indices of two medias like n1 and n2, and if it is asked that what is the value for critical angle for any media, you can utilize this expression to find it out, right? So examples and assignments, even numericals, are based also on these expressions. Okay, so this was all about today's lecture. This was total internal reflection. Now let me summarize today's work, what we have done. Okay, look, we have discussed three topics today. The first was refractive index. Refractive index was what? Refractive index was a kind of a ratio between sine of angle of incidence to sine of angle of refraction. N is equal to sine of I divided by sine of R. And secondly, second definition was the ratio of speed of light in air or vacuum to the ratio of speed of light in any media. Okay, so we can say that N is equal to C by V. And do remember one thing, dependence, that refractive index depend upon the material medium's value also. It depends upon the nature of the material medium also. Okay, refractive index will be always greater or equal to 1. Okay, it has no unit. Why? Because it was a ratio between two similar quantities. And then we have moved towards Snell's law. You know, Snell's law was presented in 1621, and it is quite simple. We have stated is also, and it can be explained like the product of refractive index of the first medium with sine of angle of incidence is equal to the product of refractive index of. Okay, so refractive index we have done. We are going to discuss Snell's law. In Snell's law, we have discussed that the product of refractive index of the first medium with sine of angle of incidence is equal to refractive index of second medium with sine of angle of refraction, known as Snell's law, right? Now we are going to discuss total internal reflection. We have already discussed it. Okay, we are summarizing it now. Critical angle is that angle for that incident angle for which that incident angle in rare medium for which angle of refraction in denser medium is 90 degrees is known as critical angle. We know that when we were discussing refraction of light, so we have said that over there, when ray of light enter from a denser to rare medium, it bends away from the normal. The same diagram we are going to draw over here. Look, we are having air, which is denser medium, air is rare medium, glass is denser medium. Ray of light is coming and bending away from the normal. Over here as well, over here as well. Look, over here what is happening? Over here the angle of refraction is 90, so that incident angle for which angle of refraction is 90, so that incident angle will be called as critical angle. Okay, after this critical angle, if further rays are coming, they will be not refracted in the above medium, but all the rays will be reflected in the same medium from where they are coming. Okay, the basic necessary condition for total internal reflection is the ray of light must enter from a denser to rare medium. Number 2, the angle of incidence must exceed the critical angle associated with the material. And for mathematical description, we have used Snell's law. Instead of this theta I, we have used C, and instead of this theta R, we have used 90 over there. Sine 90 is equal to 1. So by calculation, we have got sine C is equal to N2 by N1. So this was all about today's lecture. Hope you have enjoyed it. Thanks for watching. Allah Hafiz.